Okay, today we're going to talk about the concept behind the unit circle. And the unit circle is mainly based off of two special triangles that are important to understand. Because on the unit circle, all the values kind of repeat themselves. You just kind of have to spatially be aware of where that triangle has been kind of rotated. So it's kind of taking you back to geometry, obviously, a little bit. Um, the first special triangle that we have is going to be a 30, 60, 90. And we'll have our 30, our 60, and our 90. Well, anytime you have a triangle like this, the sides are always the same, right? Because it's similar triangles. If we had a hypotenuse of 2, the other sides would work as such. The side opposite the 30 would be a 1, and the side opposite the 60 is going to be the square root of 3. Now, this all holds perfect, because if we were to do the Pythagorean theorem, you'd see that 1 squared plus the square root of 3 squared equals 2 squared. And that is true. This is 1 plus 3 equals 4. So this is the first triangle that we're going to need to know. And this is going to be helpful because it's going to help us match up when our angles are 90 degrees, or excuse me, 60 degrees or 30 degrees away from our axes. Now, you don't need to know all of this all the time, but you'll see these numbers pop up throughout the unit circle. Your 1, 2, and square root of 3. Um, and then you also have a 45, 45, 90. Now that triangle, a little more consistent here. So we got 45, 45, and 90. Now if our hypotenuse here was 2, the other two sides set up as follows. This would be the square root of 2 and the square root of 2. And you can see that this still works because we have the square root of 2 squared plus square root of 2 squared equals 2 squared. Because this is going to be 2 plus 2 equals 4. And so this also works. And you'll see how this repeats throughout our circle. Okay, so let's move on and let's actually build our unit circle real quick. So we have a big circle, and the important part here is that you're looking at this as if it's centered on 0, or excuse me, centered on the origin. So this is your x. Up here is your y, and you're trying to figure out, as I rotate around this, how do I predict, how is this useful to me? Well, a unit circle has a radius of 1. Okay, so you get your -1 and 1, or -1 and -1. Right, so it's got this property to it. So as we rotate around, we're making little triangles. One triangle may be right here. Let's say we stop here. Say we've stopped rotating at this point. Okay, well, if you think about this, this is a coordinate point. This is a point, some xy, where our x is our x coordinate, how far away from the origin we are, which in the x direction, which is that far, and then our y coordinate, which is this leg, which is how high up we are from the x-axis. So this is how it's set up. Well, our radius everywhere is always 1. Well, it just so happens that if we were looking to find certain ideas about our angle, okay, which when we talk about angles now, we're going to use this new variable called theta. Okay, it looks like a kind of a circle with or a 0 with a little tinier 0 at the top. Okay, so kind of like an olive or something, or an I. But that's the Greek symbol for theta. If we were to look at this, you can notice that because our radius is always 1, the unit circle has this very interesting property that the x-coordinate is always the cosine, and the y-coordinate is always the sine. And the reasoning behind this is that if you think about SOHCAHTOA, so I'm going to write over here, SOHCAHTOA, okay? If you think about this, the cosine of our angle, which again we're calling theta, so the cosine of theta, that's going to be the adjacent side to theta, which is x, divided by our hypotenuse, which is 1. Well, that's just x. And our sine of theta is going to be our opposite side over the hypotenuse, which is just y over 1, or y. So if we know what our x and y coordinates are at certain points all along this circle, we can know automatically what the sine and cosine are for the entire circle. Well, the unit circle breaks its way up into our little triangles here, like we've worked on before. Oh. So the first one goes after 30 degrees. And so we have our 30, our 60, and our 90. The next one is after 45 degrees. Oops. Getting progressively worse here at this. So this is 45, 45, and 90. And so on around the circle. We still have these repeated over and over, right? So this is also 45, 45, and 90. The difference between these two is what? Right? This has a coordinate xy. This one is a coordinate negative xy. So the sines of these angles are the same, but the cosines are opposite. Okay? So this is a 45-degree rotation. Remember, because we're all basing it off of where we are in the unit circle. But what is this angle? This angle over here, if we think about it in terms of trig, this angle here is 45 plus an extra rotation. Okay? So this is actually a larger angle than the other one. And sometimes it's easier for us to think kind of in relative terms. This 45 is, 45 past 90 degrees, so it's 135. So the sine of 135 and the sine of 45 are the same, but the cosine of 45 and the cosine of 135 degrees are opposites. And this continues around the circle all the way around. Now, there's a quick and easy map for this, and we'll talk about this more in next class. But let me show you what the unit circle looks like. Okay, so this is what the unit circle looks like, and it looks like lots and lots of information. But again, it's all based off of those triangles that we talked about before. You got to think of this as being centered at the origin, right? So that's 0, 0. Well, the first angle in our standard position here is 0 degrees, or 0 radians. So 0 degrees, 0 radians. We have no height to this triangle, if you want to call it that. So the y-coordinate is 0. The x-coordinate is as far out as you can get, and that's a maximum of 1. And so right here, this is our coordinate 1, 0. It's also the cosine and sine of the angle 0 degrees or 0 radians. Okay? That's what it is. If we move to our second angle, which is at 30 degrees, right, this is a 30, 60, 90 triangle. So kind of like before, we have this particular setup where we have, if we look back at the beginning, we have these numbers, square root of 3 and 2 and 1 over 2. Well, if we go back to our setup here, you'll see that the cosine, which is our adjacent side, which was the square root of 3, and our hypotenuse was 2, and technically these are all downgraded because the hypotenuse is 1, but you see that our cosine here, because this is a 30, 60, 90 triangle, is the square root of 3 over 2. And the partner with the square root of 3 over 2 is always going to be some form of a half. Okay? So that's why these two things are paired up. They look strange together, but they work very, very well. And you can see we have, for 30 degrees, our radian measure is pi over 6. This is all important information to know, because eventually we're going to want to just know this without ever having to look at a unit circle. And the other example that I gave you before is the 45, 45, 90 triangle. Okay? Now, we said that we had, the sides were arranged in this way, the square root of 2 over 2, and the square root of 2 over 2. Okay? Now, that's for 45 degrees. That makes sense that our sine and cosine would be the same, because the x and y are both the same size. Our x is the square root of 2 over 2 away from the origin, and our y is the square root of 2 over 2 from the origin. Now, when I talked earlier about how we use this same triangle around the circle, let's look at 135 degrees. Well, as I was showing you earlier, the sines are the same, right? We're the same height off of the y-axis, but we're the same distance away from the x-axis, we're the same height off of the x-axis, but we're the same distance away from the y. But because we are now to the left of the y-axis, we're in the negative x range, our cosine is going to be negative, and our sine is going to stay positive. And you can notice this, as you go around the circle, the coordinates make sense, right? In the third quadrant, where our x's and y's would be negative, our sines and cosines are all negative, okay? And likewise, in the first quadrant, where all our coordinates are positive, all our sines and cosines are positive. So this is just kind of the theory of how the unit circle works, why these numbers exist the way they do. And we'll get into more of the logic of how it works, but if you can spatially see how the unit circle is arranged, and you understand these two triangles and how they work together, then we can be successful in memorizing and understanding the unit circle.